Today, what we're doing is we are taking limits. We're trying to figure out what limits are. And it's this new math word. We've never seen it before. And it's spelled limits, L-I-M-I-T-S. It is, that's it, okay? It is abbreviated L-I-M for limit. Now we have a couple of parts of this idea of limits first. We have this idea of x approaches a number, let's call this 3, of x plus 3, okay, equals. Now, I'm going to tell you this idea here. We've seen the way in algebra and algebra 2 and precalculus, we write stuff like, hey, what is f of 3? Okay, if f of x is equal to x plus 3, then what is f of 3? Don't we just plug it in? And we say, well, f of 3 is 6, because 6 is 3 plus 3. If I plug in 3, 3 plus 3, that's 6. We've done that. We know what that is. This is, right? It is 6 when x is 3. But limits take a different view. And you might see them as kind of minuscule and kind of lame. Again, it might be minuscule, kind of lame. But limits say, what should it be? Now, what should it be? If I said, what should the graph look like when x is 3? Let's go ahead and graph this. 1, 2, 3. 1, 2, 3. And then what happens to the graph looks like when x is 0, y is 3. Okay, when x is 3, what does the graph look like? What do you think that value looks like? Well, the way we find that out is we plug it in. 3 plus 3 is 6. Now, how is that any different? How is that any different compared to what we've been doing already? Okay. How is it any different compared to what we've been doing already? So in your last homework, this is what you guys were working on, right? In your last homework, we said limits are what should it be? What does it look like? And that wasn't hard. And when it comes to functions, when it comes to graphs, they gave it to you. But what if we take a step now and ask ourselves, what does it look like here? The graph looks like, the graph of f of x is equal to 1 over x. Oops. Okay. Now, we have a lot of places that we can pay attention to, but I wonder if you can agree with me that there's some weird stuff going on in the graph. For instance, this goes to infinity, this goes to negative infinity, this is headed toward a number, that's headed toward a number. So I'm going to go ahead and label what they're headed toward. They're headed toward, on the right, this is headed toward infinity. It's this going down, it heads for negative infinity. On the right, it looks like we're heading towards 0. On the left, it looks like we're flattening out to also 0. These special points, we have a way of describing them before. Because in math before, we had no way of describing what was happening. If I ask you to try to describe in algebra 1 terms, what happens to this graph as this graph keeps going to the right? Could you plug in wouldn't you just plug in a big number? Hey, what's f of 10? What's f of 100? What's f of 1000? In algebra 1, that's how we would talk about it. So you would tell me, for instance, this would be, 1 over 10 is 0.1. 1 over 100 is 0.01. 1 over 1,000 is 0.001. Yeah, you're right. There's nothing wrong with this. These are the actual points. But what would it look like? What does a limit look like as x goes to infinity? As x goes on its journey, its little pilgrimage, what happens to the y value? Is it going to get any bigger or any smaller? Or are we just going to kind of get stuck there? And hopefully you'll notice that the value gets closer and closer to 0. Here's what I need to tell you this. It never touches 0. It never touches 0. But isn't that what it's supposed to look like? If I could get to theoretical infinity, if I could walk to the end of the universe, if that's possible, what would it look like? Can you send me an Instagram shot? And the Instagram shot here would say, hey, if I made it to infinity, it would be 0. What would the limit be as x gets closer to negative infinity of f of x? Fine, let's go this way now. What would the y value be? So if you can see here, I'm climbing up, 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 up. I'm getting a little bit higher, making a little more money. But what value do we look like we're gonna hit? And hopefully you're agreeing with me that it looks like we're getting closer to 0. And that's what we called here my horizontal asymptote, if you remember that. Horizontal asymptote. We had a horizontal asymptote of 1 over x is 0 because the bottom variable was bigger. We mentioned that before. If the bottom exponent of the variable is bigger, eventually the graph gets bigger, bigger, bigger. 1 over 100, 1 over 1,000, 1 over a million. 1 over a million is pretty much nothing. Okay. If I tell you, oh, I'm a shareholder of Amazon. I own 1 share, 1 out of 2 million shares. How much of Amazon do I really own? Can I walk into Amazon and say, hey, that's mine, that's mine, that's mine? No, I'm a shareholder. I own nothing, okay? Jack. So the idea of what does the limit look like as x approaches, what does the function look like as x approaches infinity? They both are 0 here. Now we're going to spin this around and say this a little differently. What is the limit as x approaches, 0 from the right? And what is the limit as x approaches 0 from the left? Okay, so what is the limit? Looking at this picture, we have 2 different sides. Here's 0. I need you guys to all make sure you guys see where 0 is. 0 is right here. This is 0. That's 0, right? Now, what does the graph look like? What's the y value as I get closer from the right side? And I get closer from the left. Okay, these are 2 different people. You and your brother, you and your sister, you and a family member are approaching the same point from 2 different angles. You see things in a different way, right? Imagine if you're on a plane trip and one person was sitting on the right side of the plane and one person was sitting on the left side of the plane. The person on the right side might see Vegas. Oh, look at those lights. That's amazing. A person on the left side sees what? Nothing. Because there's nothing out there. So that's why I need you to tell me, what does it look like from the right side? What does it look like from the left side? So we have a little notation here with a plus and minus. This little plus and minus is super important for us. So as x is getting closer to 0 from the right side, what does that look like? As I head closer to the y value, the graph itself is getting higher, 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 higher. Am I ever really going to touch 0? Am I ever going to cross over? Is it going to be doing this weird thing? Nope. There is a vertical asymptote there. We talked about it before. At 0, can I divide 1 over 0? That is impossible. We said it's undefined because it's infinity. Remember, if you remember my example of cutting a cake, how many slices do you want? I want a 0 size slice. How many slices can I have? Infinite. You're not getting anything. This is going to be infinity. In this case, we're going to put positive infinity for us. On the left side, as I approach the graph on the left side, you can see that this graph is tanking downward. It's going to hell. Sounds like a horror movie. To hell. What does it look like? It looks like hell. Right? Yeah, what does it look like? Hey, were you there? Were you at hell? No, it just looked like it. Okay? It looked like hell. All right. So that's our starting point. So let's go ahead and look at your IXL task and see what you guys have to do today and see if it kind of makes sense, okay? Let's go to IXL. All right, so this example, let's go to read the directions. The graph shows f of x. The dashed line is a vertical asymptote. So they're telling us right now that this dashed line is, we don't exist here, right? We're gonna end up dividing by 0. Okay, we're gonna end up dividing by 0. Now, which of these statements are correct? We have 2 statements to worry about. And let's look at the similarities. They both have a limit, yeah. They both have f of x, yeah. They both have limit as x approaches 3, x approaches 3. And they're both from the plus sign, right? They're both talking about the same exact statement. Now, which of these statements are true? Well, let's read the statement again. The limit as x approaches -3. Okay, here's -3, -3. From the plus means right. That's from the right side. So I am not on this roller coaster on the left. I'm on this right side. I'm on my little minecart wagon, and I'm going. What does the graph look like? It looks like, oh, shoot. I never even got to -3. But what does it look like? It looks like negative infinity. So as I get closer to -3, what does the y value look like? It looks like I went down to hell. I went down to -infinity. Hard topic? Not really. What happens if I wrote this limit as x approaches -3 from the negative left side? So from the left side, I would also be going to -infinity. Looking at the graph. These are all graphing. All you're doing right now for the last 2 days is just looking at the graph and telling me what does it look like. Okay, let's look at the next one. So let's take a look. We said it was going to be -infinity. Excellent. Well done. Well played. Let's jump a couple of problems here. Let's look at this one. This looks like a interesting graph to us, yes? And the question is, once again, which of these is the correct limit? Okay, so let's look at the similarities. They both want to say limit f of x, same function, as x approaches 7, but 7 from the left or 7 from the right. So this isn't -7. This is 7 from the left. So let's look at, this is the right. This is the left. So let's hop on our Minecraft cart. Here we go. As we get closer to 7, oh man, the train tracks head down. Will we ever actually hit 7? We never made it. Poor Minecraft person. But where did he end up? It looks like he went in the nether, I guess. Okay. So -infinity. You can see that the idea of us being able to describe something in a math way now. And the math way is saying, what does it look like? It looks like -infinity. And this is 100% correct. Okay. Okay. With -infinity, here we go. That's it. Easy peasy. Let's go ahead and jump a couple more. Now this one looks a little bit crazy. There's a lot more vertical asymptotes going on. A lot more vertical asymptotes here. So we have a vertical asymptote. Let's just figure it out. We have vertical asymptote at 5. We have one at -1. Okay. But they want us to say, hey, we're looking at 5 from the left or right side. Now, you might say, Ms. Go, isn't this on the left side? It is, but we're trying to get to 5, not -5, not -6, not -7. So right here, as we get closer and closer and closer from the right side, you can see that's actually looking at this section here. As we get closer to 5 from the left side, it looks like we're heading to -infinity. Okay, so that's all you guys are going to practice, so you guys don't have any problems ever reading a limit function on a graph again. We can figure out what the limits are if they give me a graph. If I simply look at it as what would it look like if I just kept going. Okay. Let's look at the next one real quick. This is G2. Now, instead of looking at left and right, we're looking to look at infinity. Hey, what happens as we go to infinity? So life isn't always like a box of chocolates, right? Sometimes it's up, sometimes it's down. But I don't care about what's going on in the middle. I care about what it looks like as I retire. What does this graph look like as I head toward infinity? So take a look here. That's going to be infinity, positive infinity. And what does the y graph look like? What does the graph value look like it gets stuck at? Maybe you guys can see it. See how it kind of gets stuck here? And that gets stuck at 8. Gets stuck at 8. Okay, and that's really what we're saying. Hey, what does the graph look like eventually? Well, this graph is going to look like 8. Okay, now one more thing I need to mention is that these problems here, us being able to read the graph is super important, okay? And graphs are super helpful to us. It makes the idea of limits super easy. Our next step is to find the limit without graphing, because it's nice that they did all the work here and they graphed it for us. But in math, we have to do things all different ways. And one way is critically thinking, hey, what if I don't have the graph? What if it would cost me more time to graph it than for me to find an algebraic way of figuring this out, okay? So let's do, see if I can find one more interesting problem here. These are not interesting at all. Kind of boring. Okay, yeah, forget it. That's it. So after today's lesson, next time I see you guys, we will be looking at how to find limits without a graph. And that will use all the skills we've learned so far in precalculus. Precalculus, we looked at sine, cosine, we looked at graphing rational functions, undefined. So all these things that we're going to be using this vocabulary as we solve for limits without a graph. Okay, and that's it.